Hi, in this video, we'll review how to use the Classiq executor to run quantum circuits on live quantum hardware. We'll demonstrate how to take circuits you've built in the Classiq platform and run them on both quantum simulators and on cloud-deployed quantum computers. Let's get started. The Classiq executor allows you to easily execute quantum programs on different quantum hardware vendors. As its inputs, the executor uses quantum program instruction sets like OpenQASM and a specification of the quantum hardware to execute on, such as IonQ's hardware. It's important to note that in order to use some hardware providers, you may require an appropriate account with them. This is an example of an execution file. Here we specify the number of shots we want the system to perform, the name of the backend service provider, and the name of the quantum system we'll run the algorithm on. In this case, we're using IBM's Quantum AER simulator. Once this file is set up, execute the command execute quantum program. Choose a quantum program and name the file, and voila, we've just executed our quantum program. To do this in the Python SDK, you call the executor and specify the same parameters, the number of shots, the backend provider, and the circuit you'd like to execute. Certain quantum programs may require amplitude amplification or amplitude estimation. We'll show you a couple of these examples. Here you see a Grover's algorithm we just generated in the Visual Studio interface. I'll now open my executor file, and here you see that I've specified an amplitude amplification where I've chosen a growth rate of 2 and for the algorithm to not sample. I'll now run the Grover's algorithm with amplitude amplification by executing the command execute generated circuit. Here we use the command execute generated circuits instead of the execute quantum program we used previously. The command execute quantum program will run a given quantum circuit as is. The command execute generated circuit that we just used, however, will instead read a folder's JSON file along with the given quantum code and generate a quantum circuit before running the algorithm. This is particularly useful as you only need to specify the important aspects of your circuit, such as the Grover algorithm or financial model, as we'll see next. In our next example, we'll execute a quantum circuit built using our finance application suite. Here you see an example of a quantum risk analysis program generated using Classiq's Python SDK. At the end of our code block, we'll add in a call to our executor and specify an amplitude estimation with an alpha and epsilon of 0.5 and a binary search threshold of 0.05. I'll now run the risk analysis algorithm with an amplitude estimation and wait for the results. The amplitude estimation algorithm takes a state preparation circuit and uses it within Grover's operator to assess the probability of the good states. The algorithm ends with an inverse QFT applied to the evaluation qubits, which can be measured to obtain the required probability. The Classiq platform thankfully handles all this for us. We hope you found this video helpful. Thanks for joining us at Classiq.